So now, dear student, there is a turning point in this chapter, and that point is a unit vector. Unit vector, this topic will definitely change the entire concept of the chapter. In short, from this topic, now your chapter will be changed. So it's my advice to all of you, please try to understand this topic heartily, because it's a most fundamental topic, not only related to this chapter. Actually, this topic will helps you in 12th standard also. So let's understand the concept of unit vector. Actually, in textbook, in NCERT textbook, more detail about this topic is not mentioned. Definitely about unit vector is mentioned in our textbook, but in a detailed way is not mentioned. So we will understand this topic in a very detailed way. So unit vector, definition of this word is very simple. Unit vector means a vector whose magnitude is 1. Always remember, a vector whose magnitude is 1, then this vector is known as a unit vector. So definition of this word is a vector having unit means 1, a unit magnitude is called unit vector. It's a simple definition of this word. Whenever this word you observed in any MCQ or in any sum, always remember one thing. Agar if you observe this word unit vector in any MCQ, okay, in any sum, immediately your mind should recall this concept that unit vector is written, it means its magnitude is 1. Now its symbol, that this word unit vector is specially represented by which symbol? So, and it is represented by, now I'll write the symbol. How to read this symbol also I will tell you. These are the symbols of unit vector. This is simply alphabet N, but over that you will see this hat. How to read this? So remember, this can be read in this way: N caret, N caret, C-A-R-A-T, N caret. Also no represented by U caret. So this hat, whenever you observe, especially in A groups, in maths also, those who are in A group, this will also comes in the maths also. Whenever you see this type of hat, this type of symbol in 11th science in any chapter, okay, in 12th science in any chapter, whenever you see this type of symbol, below that whatever the alphabet doesn't make any difference, but if you observe this hat type symbol, immediately you should understand that this symbol represents the unit vector. N caret, always remember, unit vector is represented by either N caret, also represented by U caret, and its magnitude is 1. For example, suppose let's consider this is one vector. Maybe this vector represents force, maybe velocity, whatever. Suppose let's give the name, this vector is vector A, and suppose its magnitude is 4. For example, suppose this vector is a vector of force, to 4 Newton. This vector is a vector of velocity, to 4 meter per second. Suppose its magnitude, remember magnitude is denoted by mod. Suppose its magnitude is 4 unit. Since the magnitude of this vector is 4 unit, so it means that this is not known as a unit vector. As I said that earlier, a vector whose magnitude is 1 then is known as a unit vector. Now I'll draw another vector. Suppose this is another vector. See, first of all, this another vector is in the direction of vector A. But suppose its magnitude is suppose 1 unit. Its magnitude is 1 unit, that's why is known as a unit vector. This is known as a n caret a. Why I'll write a in the suffix? Because of this is definitely a unit vector because its magnitude is 1, but this unit vector is in the direction of vector a. That's why is known as a n caret a. N caret a means unit vector in the direction. Unit vector in the direction of vector a, denoted by n caret a. So from that much discussion, do not bother about. From that much discussion, only remember one thing. Unit vector means its magnitude must be 1. Let's move forward. For example, now this is very important, dear student. Consider this is x-axis, this is y-axis, and this is z-axis. Actually, you should know that x, y, z axis are mutually perpendicular to each other, like that. For example, this pen represents x-axis, this pen represents y-axis, so this pen represents the z-axis. Actually, it comes towards you, z-axis. X, y, z coordinate system. All three axes are mutually perpendicular to each other. So consider x, y, z coordinate system. Now I'll write coordinate. This is origin. Okay, this is suppose 1, 2, as on. Here also suppose this is 1, 2, as on. Here also 1, 2, as so on. Now look at this vector, red color vector. From the diagram, it is very easy to say. If anyone asks you what is the magnitude of this vector, so answer is 1. So this vector is a unit vector, definitely, but in which direction? So this is the unit vector in x direction. Always remember, unit vector in x direction is represented by I caret. This is also unit vector, but in y direction is represented by j caret, and this is also unit vector, but in z direction is denoted by k caret. This is most important, present in every chapter now next onwards. In 12th science also remember, I caret, j caret, k caret, I caret is a unit vector in x direction, j caret is a unit vector in y direction, and k caret is a unit vector in z direction. Always remember, whether if you forgot this symbol, it's okay, but do not forget this symbol. I caret, j caret, and k caret are the unit vectors in respectively x, y, and z directions. Okay. Now, as I said earlier that this topic will change the chapter. You will realize after this, look at here. Again, I'll consider x-axis and y-axis. Okay. Consider this is origin. Now, I'll write few coordinates like 1, 2, 3, 4, 5. On y-axis also, I'll write few coordinates 1, 2, 3, 4. Okay. Now I'll draw one vector. Look at this. Look at this vector, red color vector. Let's give the name. Suppose this is vector A. Can you able to tell me the magnitude? Yes, its magnitude is 4. Okay, look at the length. 4 is the magnitude. And this vector is in which direction? This vector is in x direction. So we all know that vector physical quantity required both magnitude as well as direction. So 4 is the magnitude of vector, and I caret represent that the vector A is in x direction. So equation, look at this red color vector, its magnitude is 4, and since is in x direction, so along with that I caret is involved. And I caret is actually the unit vector. Unit vector means its magnitude is 1. Its magnitude is 1. Now 1 4 is always 4. 1 4 is 4. 4 1 is 4. But I caret represents the direction also. So this will become equation of vector A. Vector A is equals to 4 I caret. 4 is the magnitude. I caret represent that vector A is in x direction. Similarly, suppose look at the another one. Look at the another vector. Suppose this is vector B. This is vector B. Can you able to tell me the magnitude? Magnitude is 3 and this vector is in which direction? Y direction. Along with y direction, j caret is involved. So equation of this vector is 3j caret. 3j caret is the equation of the vector B. Vector physical quantity required both magnitude as well as direction. Magnitude as well as direction. So here we have two vector now on the board in the diagram. Vector A is equals to 4I caret and vector B is equals to 3j caret. Now according to parallelogram method, complete the parallelogram. Okay, after completing the parallelogram, draw the diagonal. Diagonal is the resultant vector. This is actually the resultant of A and B, means this is equals to A plus B. Addition of vector A plus B. Let's give the another name is equals to R. Resultant vector R is the resultant vector, resultant of vector A and vector B. And mathematically, you all know that coordinate of this point is 4 is the x coordinate and 3 is the y coordinate. So look at the blue color vector. Blue color vector. So here in this diagram we have, think very simply in the simplest way. In this diagram we have three vector. This is vector A 4I caret. This is vector B 3j caret. Now this is vector R, resultant vector. What is the equation of resultant vector? Resultant vector is A plus vector B. Vector A means 4I caret plus vector B means 3j caret. This is the equation of resultant vector. So now in this diagram we have three vectors and we have their equation also. Here vector A is equals to 4I caret, vector B is equals to 3j caret and resultant vector R is the resultant vector. R is the resultant of vector A and vector B. Vector A and vector B, the resultant is R. So therefore resultant vector R is equals to 4I caret plus 3j caret. This is the equation of this resultant blue color vector. Now, how to find the magnitude of this resultant vector? That is most important. We all know Pythagoras Theorem. According to Pythagoras Theorem, this side is of length 4. This side is of length 3. So hypotenuse is definitely is of length 5 according to Pythagoras Theorem. Magnitude of this resultant vector is 5. How to find the magnitude? Magnitude of resultant vector. R is the resultant vector and its magnitude, remember, is denoted by mode. If you put a vertical bar, mode, it represents the magnitude. How to find the magnitude? So, okay, look at this equation. Actually, mathematically we know that this is x coordinate, this is y coordinate. This is x component, this is y component. So first of all, write the component. 4 is the x component, 3 is the y component. Now rule, remember this sentence throughout the 2 years. That is most important, will helps you in 12th science also. How to find the magnitude of any resultant vector? So answer is, these are the components, square root of the square of the sum of the components. Again I will repeat, square root of the square of the sum of the components gives the magnitude of any resultant vector. Here it's in a 16 plus 9 is equals to under root 25 is equals to 5 unit is the magnitude of resultant vector. So in this way, again I will repeat the sentence, square root of the square of the sum of the components gives the magnitude of resultant vector. I will give you one example. For example, if MCQ is like that, vector A is equals to 3I caret plus 6j caret, then mode A is equals to blank. mod A means they ask us to find the magnitude. So if you look at the solution, if you find the magnitude, if you would like to find the magnitude, so here 3 is the x component, 6 is the y component. Square root of the square of the sum of the components gives you the magnitude. Under root 9 plus 36, 6 square 36, 36 and 9, it's in a 45. So square root of 45 is the magnitude of this vector A. Always remember, square root of the sum of the components gives the magnitude. One more point, here right now this resultant vector is in 2 dimension, is in xy plane. But agar the vector is in 3 dimension, look at the another MCQ, vector A is equals to 2i caret plus 2j caret plus 2k caret. Then find the magnitude, find the magnitude. So rule is as it is. If you would like to find the magnitude, so here 2 is the x component, again 2 is the y component, and 2 is the z component. X component 2, y component be 2, and z component be 2. Rule is as it is. Rule is square root of the square of the sum of the components gives you the magnitude of the vector. So here the magnitude is 4 plus 4 plus 4. 4 plus 4 plus 4 is under root 12. Under root 12 is the magnitude of the vector. So always remember how to find the magnitude of any vector. Rule is only one. Square root of the square of the sum of the components gives you the magnitude. Don't worry students, we will understand so many sums in from the textbook as well as out of the textbook, so definitely will be clear. But this topic, as I said earlier, that very well not explained in the textbook. You should know at least that much point. Point number 1, unit vector means its magnitude should be 1. Second point, you should I caret is the unit vector in x direction, j caret is the unit vector in y direction, and k caret is the unit vector in z direction. Point number 3, how to find magnitude of any vector. Answer, square root of the square of the sum of the components gives you the magnitude of any vector. So this 3 point you should keep in your mind throughout the 2 years. More will be clear once we start the sums related to this topic from the textbook as well as out of textbook. So let's move forward to the another topic. So dear student, let's understand 3 MCQ which is related to the topic unit vector. Just we finished. Actually, it's better to understand this 3 MCQ before start the new topic. So that's why let's understand this 3 simple MCQ. Out of that, this MCQ was asked in the JEE examination also in the 2015. So this 3 MCQ which is related to the topic unit vector. First MCQ, I caret plus j caret and mod means magnitude. Okay, the question is they ask us to find the magnitude of I caret plus j caret. Magnitude of I caret plus j caret. Okay, here x component is 1 and y component is also 1. So x component is 1 and y component is also 1. Now rule is square root of the square of the sum of the components gives you the magnitude. So it's very simple, it's a magnitude is root 2. So answer of this first MCQ is root 2 is the answer of the first MCQ. Another one, magnitude of I caret minus j caret. I know that you should think like that, I caret plus j caret its magnitude is root 2. Now I caret minus j caret its magnitude is 0. No, you are wrong. Follow the steps, follow the sentence. Here x component is 1, y component is minus 1. X component is 1, y component is minus 1. Now rule is square root of the square of the sum of the components gives you the magnitude. So here 1 square is 1, minus 1 square is also 1. So 1 plus 1 root 2. So answer is also here root 2. Whether the vector is I caret plus j caret ke I caret minus j caret, their magnitude will be same. Their magnitude is root 2. Okay. Now next MCQ, dear student, is if vector A, one equation is given. From this equation you should understand that this given vector is in 3 dimension. It has all 3 components, 0.5 I caret plus 0.8 j caret plus c k caret. This is vector A, and is also very well mentioned that vector A is a unit vector. Acha, is a unit vector means its magnitude is 1. So what will be the value of C here? Okay, vector A, let's find its magnitude mod. Here x component is 0.5, y component is 0.8, z component is C. Now rule is square root of the square of the sum of the components gives the magnitude of vector. Since vector A is a unit vector, it means that its magnitude is 1. Why 1? Because vector A is unit vector, that's why its magnitude is 1. Is equals to under root of 0.5 square is 0.25, 0.8 square 0.64 plus c square. Okay, to remove the square root, you have to take the square on the left hand side. 1 square is equals to 0.25 plus 0.64 plus c square. And we know that 1 square is 1. Addition of this 2 is 0.89 plus c square. So c square is equals to 1 minus 0.89. So c square 1 minus 0.89, 0.11. The value of c is under root of 0.11. This is the answer of this MCQ. Value of c is under root of 0.11. So get it, dear student, this is a simple MCQs. Tough MCQs also we will understand, but once we understand few more topics, after the understanding of few more topics, definitely the hard sum also I will put in front of you. Through that your logic will be built up. So now let's start the new topic. Okay, let's move forward. So now let's move forward. Again a simple topic. Name of the topic is resolution of vectors. In the other way you can also say that components of the vectors. So components of the vectors in the 2 dimension as well as in 3 dimension. More clarification. For example, dear student, let's consider this is y axis. Okay, consider this is y axis and consider this is x axis. Remember that I will explain the meaning of this component of vector means what. So in the language of maths, this is known as a xy plane. This is xy plane. Now I assume one vector in xy plane. If anyone asks you that vector is where, let's give the name A. Vector A is where? So you can say that vector A somewhere lying in the xy plane. Okay, now this vector, we all know that this is known as a tail of the vector, this is known as a head of the vector. Now, from the tail and from the head, draw the perpendicular line on x-axis. From the tail and from the head, this is the perpendicular line, draw one from the head and tail on x-axis. So, look at that part. We can say that this is the projection of vector A on x-axis. Okay, in the very simple language, dear student, in a very simple language, I know that you understand the meaning of shadow. This is vector A and this is the shadow of the vector A on x-axis. Vector A and its shadow on x-axis. Shadow, you can say shadow also. Instead of shadow, you can say projection, you can say component also. This is vector A and this is its x component. Shadow of the vector A on x-axis is known as the x component, denoted by AX. Now in the same way, from the tail and from the head, if you draw the perpendicular lines on the y-axis, so that much part, look at this part. This is known as a shadow of the vector A on y-axis. Vector A has two shadows. We can imagine two shadows. Vector A, it's x projection and this is the y projection. Y projection is denoted by AY. So in this diagram is very clear, vector A has two components. It's x component and vector A, it's y component. There are two components of the vector. Now think logically yourself. Agar in xy plane, agar in xy axis, if any vector is like that, so this vector has how many component? Think. Answer is this vector has only one component, because you can draw the perpendicular line from head and tail only on the x-axis. This is the x component. Its y component is not possible. In the similar way, if any vector is like that, so this vector has only y component. It has only y component. Its x component is not possible. But if any vector is somewhere in cross, so this vector we can think it's two component. This is the x component and this is the y component. So here in this diagram, vector A has two component. Vector A has two component. X component denoted by AX and y component is denoted by AY. Right now this vector is in 2 dimension, means in xy plane, but agar the vector is in 3 dimension, then it has 3 component, AX, AY and AZ. AZ is the Z component. Okay. Now I think it will be clear. Now I'll just add one line for the geometry and I'll put here angle theta. Can we say that vector A makes an angle theta with the x-axis? With the x-axis, vector A makes an angle theta. Now I'll give the name of this triangle PQR. Look at this triangle PQR. Now I'll use this triangle. All the time I'll use the same triangle. I'll use this triangle 4 times. 4 times I'll use the triangle. We will get 4 times 4 result. Okay. First time I'll use the Pythagoras theorem, simply Pythagoras theorem in this triangle. So according to in triangle PQR, use the Pythagoras theorem. Hypotenuse square PR square is equals to PQ square plus QR square. Adjacent side square plus opposite side square is equals to hypotenuse square. So I'll use the Pythagoras theorem. Now let's put the value. You can see from this diagram, PR is actually what? Is vector A. But see here arrow is not there, so I'll write only A. I'll not put arrow, I'll write only magnitude. A square is equals to, now think PQ. P to Q is equivalent to AX. So PQ square means AX square. QR, look at the QR. QR is equivalent to AY square. So that's why remove the square, take the square root on the right hand side, AX square plus AY square. We will get this equation. Try to recall this. We will understand in the previous MCQs also. Actually this equation tries to tells only one thing. Left hand side, see arrow is not there. It means only A means magnitude. How to get the magnitude? The rule is square root of the square of the sum of the component. Look at that x, AX and AY are the components of the vector. Square root of the square of the sum of the components gives you the magnitude of the vector. That was our previous result. We understand in the previous topic also. Okay. So this is the first time I'll use the triangle. Now second time I'll use the same triangle in triangle PQR. I'll use tan function, tan theta. We know that tan theta is equals to opposite side upon adjacent side. Tan theta is equals to opposite side means QR and adjacent side means PQ. So that's why tan theta is equals to, QR, look at the QR. QR is equivalent to AY. QR is equivalent to AY. and PQ is equivalent to AX. Okay, so through that equation we can find the theta also. Agar if you know the value of AY in AX, then through that we can find the function theta also. Okay, by this vector makes how much angle with the x-axis can be determined through this equation. Let's call it, this is equation number 1, this is equation number 2. Now most important, I'll use again the same triangle, in triangle PQR. This time I'll use cos function, cos theta. You should know cos means adjacent side upon hypotenuse. Adjacent side means PQ upon hypotenuse means PR. In the same triangle PQR, I'll use the sine function also, sine theta. Sine theta means opposite side upon hypotenuse. Opposite side means QR. Hypotenuse means PR. Let's put the value. Really, dear student, it's most important. Let's put the value. So cos theta is equals to, acha, PQ, look at the diagram, P to Q is equivalent to AX and PR is equal to A. Similarly here, sin theta is equals to QR, look at the QR is equivalent to AY, PR is our vector A. So from this equation, AX equals to A will go in the left hand side in the multiplication of cos theta, A cos theta. And from this equation, AY is equals to A sin theta, A sin theta. So now this is our equation number 3 and this is equation number 4. See, these equations are the equations to find the component. AX is the X component, AY is the Y component. So according to this diagram, vector A has two components. X component is A cos theta, Y component is A sin theta. To find the X component A cos theta, vector A has two components. X component is A cos theta, Y component is A sin theta. These are the equations to find the components of the vector. Now, use of this equation will be very much clear once you start solving the sums and MCQs. So far, whatever we studied, that will be clear after few sums and after few MCQs. One more point. Right now this vector is in 2 dimensions, so it can be represented in this way. Vector A is equals to AXI caret plus AYJ caret, because it has two components, X component and Y component. But agar the vector is in 3 dimension, then in a 3 dimension vector A can be represented in this way, AXI caret plus AYJ caret plus AZ K caret. Okay, so here this vector represent that the vector A is in 2D, 2 dimension. This vector is in 3 dimension. These are the ways, is the resolutions of the vector as well as components of the vector.